Hello, welcome to Screencast on Anatomy and Physiology and the Cardiovascular System. As you'll remember, last lesson we had a look at structure and function of the heart. So we looked at the splitting of the left and right atrium and ventricles, and then we had a look at how the conduction system and the cardiac cycle link together in order to formulate a heartbeat. So what we have to look at now, we've got that basic understanding of the heart. Now what we have to do is have a look at the relationship between heart rate, stroke volume and cardiac output. Now anybody who did a BTEC or GCSE will have an understanding of these terms. The key focus of this screencast and also tomorrow's lesson will be, we have to know first of all the link between these. Secondly, we have to look at how you describe the changes of each of them during exercise. Now I'm sure everyone could understand that if you start exercising, your heart rate increases, your stroke volume increases and so does your cardiac output. You need to understand why. So what we're going to do is we're going to look at a general relationship between heart rate, stroke volume and cardiac output. Then we're going to split them up. So we're going to look at the heart for a lesson, then we're going to look at stroke volume, then we're going to look at cardiac output. So the big focus of tomorrow's lesson will be, if I was going to have a graph, how would I describe the changes that happen to heart rate during exercise? Secondly, how does the body cause our heart rate or allow our heart rate to increase during exercise? So this is your relationship. This should be in your core now notes. So the relationship between heart rate, stroke volume and cardiac output is as follows. Heart rate times stroke volume equals cardiac output. What does that mean? Well, it means the number of times your heart beat in a minute times the amount of blood that is ejected from the heart per beat equals the amount of blood ejected from the heart per minute. So you can start to see now that there's a kind of some subtle differences here. Heart rate is just the number of times the heart beats in a minute, or ventricles. Stroke volume, the amount of blood ejected from the heart per beat. I always think with this, it's called stroke volume, not strokes volume. So just remember, it's the amount of blood ejecting from the heart per beat. That is not a plural. That's a singular, stroke volume per beat. Okay, then you've got cardiac output, the amount of blood ejected from the heart or ventricles per minute. So that basically refers to how much oxygenated blood we can get to our muscles in order to exercise. Now, as you can see, these things, you have a general, when you're sat down, this will all be at resting value. What we need to understand is, can we describe the changes that take place to heart rate during exercise? After we've done that, we'll look at these two, but this is going to take at least a lesson to have a look at the different ways our body allows heart rate to increase. So, first up then, if we have to describe the changes that take place to heart rate during exercise, we need to know certain things, and I'm going to ask you to do the following. You would have your first heading would be your define heart rate, stroke volume, cardiac output. Now what we're looking at, this will be your next heading, describe the changes that take place to heart rate during exercise. A couple of things we need to know. First up, we need to know the resting value. So what we're going to do, if I can just get you to subhead under here, you need to have describe the changes that take place to heart rate during exercise. If you can just label here, submaximal equals red, maximal equals blue. Now what I'm going to do is kind of give you this information. In the exam, you will be expected to talk about 5 to 6 changes that happen during a training run. So if you see now, you've got a slightly different. This red here is a submaximal changes that happen to heart rate during exercise. Now, submaximal basically means kind of working, obviously you can still breathe, very slow jog. If I was just going to define it, I mean, if you were going to put it into your head, you'd be saying jogging. That is what submaximal basically refers to, whereas maximal would be sprinting. So that's the difference, and what we have to understand is the difference in heart rate that happens to them. We'll start off with submaximal then. Now the first thing you have to do when you're describing the changes that take place to heart rate during exercise, you have to give a resting value. So your resting value is usually about 70 beats per minute, somewhere between 60 and 80. So if I just have a look on here, you've got 0.1. So 0.1 is the resting heart rate. As you can see, that aligns to the bottom point here. It's before exercise. You've got here a start of exercise. This is just before. This is after. So you've got those 3 sections. So the 0.1, you have to do 6 points and describe what each point is and what's happening. So 0.1 is resting heart rate, 60 or say 60 to 80 beats per minute. If you say around 70 beats per minute. Then you work out from there. The next thing that happens before exercise, if you look at 0.2, there is a slight rise in heart rate before you even move. And that is caused, and if I could tell you what it is, 0.2 is called an anticipatory rise. Now, anticipatory rise is caused by the SA node that you talked about in the conduction system. The SA node triggers this kind of heart rate anticipatory rise because of adrenaline. So when you're standing there in a 100-meter race before you go, you start to have a little rise in heart rate. Adrenaline will stimulate SA node to cause the anticipatory rise. So what is it? It's an anticipatory rise. What causes it? Adrenaline stimulates SA node. So moving on from there then, if we go on to here, point 3. So point 3 for both of these is called a steep rise. Okay, now the steep rise happens, and I think we'll come back to that. If you just put a star by that, and I'll talk about that a little bit more after we've done tomorrow's lesson. So a steep rise is caused, and then what happens here, you have two things that are slightly different for each one. For the submaximal graph, you have something called point 4 is going to be a plateau. Okay, now a plateau is where heart rate kind of flattens. So plateau will flatten, and what happens is, the reason why that happens during a submaximal when you're jogging, if you imagine you started off resting, anticipatory rise, then there's a real steep rise when you start to actually jog. When that jogging, because your demand for oxygen is met, okay, so O2 demand is met, this leads to a plateau where your heart rate just levels off, okay, and it will go, the submaximal value which you'll need for this is somewhere between, let's say, 120 and 150 beats per minute. So I've got here, I put it about 145, 150 beats per minute, and that is the plateau. So plateau is what it is, caused by oxygen demand being met, so we can get the oxygen to our muscles that we need, so there's no further spike. And then following that, your next bit is, if I go up here, there's a slight difference here, if you can see that. This, for the maximal, when you're sprinting, it's slightly different, because rather than plateauing, there is a continued rise. So your second bit is a continued rise, but it's not as steep. So you might call this, let's call point 5, gradual rise. Okay, so a steep rise from point 3. Point 4 is a plateau. Point 5 is a gradual rise. And then if we go down from there, your next bit here, you will have a steep fall for both of them, and return to resting heart rate. So steep fall, why do you have a steep fall? And this is key, point 6, whether it's maximal or submaximal, O2 or oxygen debt is repaid. So when you stop exercising, all the oxygen you're breathing in, it's repaid. So there's a steep fall in heart rate back to your resting value. So if I could say kind of key points you need to talk about here, so far, describe the changes that take place to heart rate. You're basically looking at point 1, resting value, point 2, anticipatory rise, I've said why, point 3, you have a steep rise, okay, so that is caused by, we'll just put the star there. Then you have point 4 is a plateau for a submaximal graph, point 5 is a gradual rise, point 6 is a steep fall or steep decline, and that is caused by O2 debt being repaid. So that is your first section then, and that will be kind of how you describe the changes that take place to heart rate. Now, what I'm going to do is click off this quickly. In fact, I think I'll probably finish it there. So that's 8 minutes going through your first bit. I think that's a fair bit of information to take in to start. Tomorrow's lesson, we will have a look at, okay, that's describing the picture of what happens to your heart rate. Now we need to understand how the body controls or allows us to increase or decrease heart rate during exercise and recovery. Okay, thank you.